Good morning everyone. Today in this live lecture we shall discuss the next part, limits of integrations. Here in this live lecture we shall discuss the next part, that is the limit of integrations. If there is a double integral with respect to x and with respect to y, that means there is a double integral, then how to take the limits for this integral from the given curve, we shall discuss in this live lecture. Actually this is the part, this is the fourth chapter. In that fourth chapter we have to discuss here, that is limits of integration. Then we shall move towards one by one. Actually, according to the definition of the double integral, it is the limit double integral over a which is given by limit n tends to infinity delta a tends to 0 summation r is equals to 1 to n f of xr comma yr delta ar. Okay, so these are the notes. Double integral means we have to find out the area bounded by the curve, that is double integral which is in the form of a summation. Double integral we can express in the form of integration. First integral from a to b, second integral from f of x1 to f of x2 of x comma y dx into dy. Now we shall discuss the limit, and if strip is a vertical strip, then we can write in this way. If a strip is horizontal, then we can write that integral, double integral from c to d, integral from f1 of y to f2 of y, f of x comma y dx dy. In this case we have to take first integration with respect to x by keeping y constant, and then integration with respect to y in this way. Okay, now how we can take the strip we shall discuss here. According to the theorem we have proved strip limits of the integral for the double integral f of x comma y dx dy. So how we can find the limits of this integral? Now we know that if A is a region bounded by the curve y is equals to bounded by the curves y is equals to f1 of x comma y is equals to f2 of x comma x is equals to a, x is equals to b is given by, then we can write the double integral. How we can write double integral over a means the region, f of x comma y dx dA, which is equals to, we can write integral from a to b, integral from f1 of x to f2 of x, f of x comma y dx into dy. So how we can write the limit? See this, suppose we have to calculate our area bounded by the region. Suppose this is a f of x, whatever may be. This is, suppose this is a, we consider f1 of x, y is equals to f1 of x, and we consider another function y is equals to f2 of x, this. So we have to find out the area bounded by x is equals to a to x is equals to b. So in this case, if we consider a vertical strip, this is a vertical strip, and we can find the areas regarding the rectangle which are included in that vertical strip, then in this case this lower bond here, if we consider the vertical strips here, अभी आपको क्या करना है, वर्टिकल स्ट्रिप कंसिडर करना है. सो हाँ, नाउ इन द सपोज हियर, suppose the vertical strip, in this case we have to take, in this case integration y is taken as a variable by keeping x as a constant. Means if we consider the vertical strip, then in this case first of all we have to take the integration with respect to y. That means second integration, this second integration whose lower limit is in terms of x, whose upper limit is in terms of y, in terms of x. Then we have to take this inner integral, second integral with respect to y first by keeping x constant. Now if we take this second integral with respect to y, then its lower limit and upper limits are, this is very important, then its lower limits and upper limits are the lower bond and the upper bond. This is f1 of x and this is f2 of x. These are the limits of integrating with respect to x, or limits of second integral, and corresponding the limits of first integral are the bonds on x axis from x is equals to a to the x is equals to b. So this is the concept of a limit when we consider the vertical strips. So the limits of this integral, the limits of this integral are values of y for, how we can write, for the lowest and for the lowest and the toppest, means upper position, lowest and highest point of the strip, if we consider the lowest and highest point of the strip. So if we consider a vertical strip, then its lowest point and highest point, its lowest point and highest points will be the limits of integration with respect to y, or second integration, and we have to take that integration first by keeping x constant. So then, and again these values of y obtained from, now these values of y are obtained from the equations of the curves. Y is equals to f1 of x, y is equals to f2 of x. So we can solve, and the limit of first integral will be, then first of all we have to calculate the area of strip, and by using these strips starting point and also the limits of first integral, that is with respect to x, having the starting of strips in the region, that is x is equals to a to x is equals to b. आता स्ट्रिप्स कुठून स्टार्ट होतात? दिस इज सपोज वर्टिकल स्ट्रिप. नाउ दिस इज अ फर्स्ट स्ट्रिप, this is a second strip. The starting point is A, from A is to last strip. Vertical strip किती आहेत पहा. How many you have to consider? This is the vertical strip. So lowest point and highest point of that vertical strip, which gives the limits of second integral. But there are n number of strips. So starting point of that strip in that region and n point of that strip, which gives the area. So how we can solve this? So we can write therefore double integral over a f of x comma y dA, which will be the, how we can solve? First of all, we have to keep the integration constant with respect to x. We have to take f1 of x to f2 of x, f of x comma y dy. First we have to take integration with respect to y by keeping x constant. Now in the second case, suppose if we consider case second, how to take the limits? आता बऱ्याच वेळा असं सुद्धा होतं पहा, लक्षात ठेवा. If we want to calculate the area bounded by the curve, intersection of the curve, suppose this is the first curve, this is the second curve, so this is the f2 of x, this is the f1 of x, and this is a, suppose we consider a vertical strip. So the lower limit is f1 of x of second integral with respect to y, upper limit is f2 of x. But starting of this region or is from here, this is the intersection point of both the curve A to the point B. In this way, this is the starting A to B. Okay, see this intersection point, this is the starting. So A is starting point, B is end point over the x-axis, and this is y-axis. And if we consider a strip, that is a area with respect to y, then lowest point and highest point of that considered strip is called, or the values of y, which is the second integral. Now we consider the another case second. What is that case second here? Case second. If we consider the horizontal strip, suppose if we consider the strip is horizontal, कशी आहे strip? If we consider horizontal strip, that means we have to take this. Suppose this is x-axis, this is y-axis. Suppose this is a first function which is denoted by f1 of y. This is another function which is denoted by x is equals to f1 of y, x is equals to f2 of y, means function which are in terms of y, and we have to take the area bounded by y is equals to a to y is equals to b in this way. Here in this case we have considered the horizontal strip. So how we can calculate? This is the f1 of y. See this. This is the first point, f1 of y, and this is the end point, last point, f2 of y. Then how we can calculate the area? This area bounded by the region. So here in this case, if the horizontal point if strip is horizontal, if strip is horizontal, then we have to take integration with respect to x by keeping y constant, and the limits of second integral will be the first and will be the endpoints of the horizontal strip. Horizontal strips. And so the limit of first integral will be also limit of first integral with respect to y having y is equals to a to y is equals to b. So how we can solve this? This implies that, now this implies that how we can solve this integral? Double integral from over a f of x comma y dx or dA. We can write dA, which is equals to first integral from a to b. आपण याला टाळण्यासाठी आपण a to b म्हणण्याऐवजी c to d म्हणू, म्हणजे इझी जाईल, थोडं फरक लक्षात येईल. वी कॅन राईट धिस ॲज अ c to d. ओके, नो प्रॉब्लेम. कशाला चेंज करताय, बऱ्याच ठिकाणी घेतलंय. सो द लिमिट्स ऑफ फर्स्ट इंटिग्रल विल बी y इज इक्वल्स टू a to y इज इक्वल्स टू b. लिमिट्स ऑफ सेकंड इंटिग्रल विल बी f1 of y to f2 of y, means function in between y, which is calculated from the functions x is equals to f(y) and x is equals to f1y, f2y, f of x comma y dx dy. Then how we can solve this? Here in this case, f1 of y and f2 of y are the first and last n points of horizontal strip. In this case, we have to take, this is a horizontal strip, means changing with respect to x. हे पहा, हॉरिजॉन्टल स्ट्रिप मधले जो रेक्टेंगल्स असतात, यहाँ पे देखो जो हॉरिजॉन्टल स्ट्रिप होते हैं उसमें जो भी रेक्टेंगल्स होते हैं वो चेंजिंग विथ रिस्पेक्ट टू एक्स एक्सिस होते हैं. सो इन दिस केस y विल बी द कांस्टेंट. व्हेन वी हैव टू टेक द हॉरिजॉन्टल स्ट्रिप, देन area which is calculated in that strip will be along x axis. So we have to consider x as a constant. If we move toward this, then x will be the x will be the variable, and its limits will be f1 of x to f2 of x, and we have to keep y as a constant. First of all, we have to calculate the area of strip. Then such a number of strips. Now this is a starting strip. This is first. So then we have to take the one by one strips from y is equals to a to y is equals to b. In that case, so limits of first integral will be y is equals to a to y is equals to b. So how we can calculate this integral from a to b? This is a function of y. So f1 of y to f2 of y, we can write f of x comma y dx first, because these limits of second integral are in terms of y. In terms of y, that means it has a horizontal strip. So we have to take integrating with respect to x by keeping y constant. This is the process for finding the limits and the solution of the double integral. Now we shall move towards the problem. See this, evaluate double integral from x square, double integral x square plus y square dx dy over the region in the positive quadrant which has x plus y which is less than or equals to 1. Check this problem. We have given the double integral, but there is no any limit for first integral and second integral. Check this. Suppose I is equals to double integral of x square plus y square dx dy, means double integral with respect to x, double integral with respect to y, but limits of this equation we have not given, so we have to calculate the limit. तर कसं calculate करणार? See here, suppose this is x axis, this is a y axis. To find the limit we have take the positive quadrant, means in first quadrant. The region in the positive quadrant means in the first quadrant, a condition part, region in the first quadrant in which x plus y is less than 1. If we put y is equals to 0, then we will get x 0 plus 1. This point, आता हा point काढा, so it will be the 0, 1 comma 0. Second, it can be 0 comma 1. हा condition घ्या, if we take x plus y is less than or equals to 1, or consider we have to find out the area. This is x plus y. Suppose x plus y is equals to 1, so this bounded region is x plus y is less than or equals to 1, and f of x comma y is given x square plus y square. Now how we can take the area? First of all we have to take the values of x is equals to 0. कुठून कुठपर्यंत काढायचे पहा? x is equals to 0 to x is equals to 1. These are the limits for first integral. X is equals to 0. See this, x is equals to 0 to x is equals to 1. We have to calculate the limits of first integral will be 0 to 1. When we have to calculate this limit, if we take the vertical strip, now we have to take the vertical strip. This is a vertical strip. Okay, so end point is y is equals to 0. This end point is y is equals to 0, and upper topmost point is on x axis. This is the equation of line, x plus y is equals to 1. So value of y on the line x plus y, which will be y is equals to 1 minus x. So we can write, if we consider this is a strip, if we consider this is a strip, in that strip the lowest point is y is equals to 0 and the topmost point is on a straight line, then every point on a straight line whose equation is given, that equation is x plus y is equals to 1. So every point on a y, every point having a y coordinate on a straight line is 1 minus x. So the lowest point of that strip is y is equals to 0, highest point on that strip is y is equals to 1 minus x, because we have considered y as a variable by keeping x as a constant. So we can write the limits of this integral, unknown limits. या इंटिग्रल मध्ये लिमिट्स दिलेले नाहीत, पण आपण काढू शकतो. सो इंटिग्रेशन इन द फर्स्ट क्वाड्रंट x plus y is less than or equals to 1. Let x plus y is equals to 1. So y is equals to 1 minus x. The area bounded by the lines x is equals to 0 to x is equals to 1. Origin आहे x is equals to 0 पासून x is equals to 1 पर्यंत, and the vertical strip having lowest point y is equals to 0. x axis वर लोएस्ट पॉइंट आहे आणि x axis वर y कोऑर्डिनेट 0 असतो. आता y काढायचेत ना, आणि टॉप मोस्ट पॉइंट y is equals to 1 minus 1. सो वी कैन ऑब्टेन द लिमिट्स. जे अननोन लिमिट्स होते, यहाँ पे देखो इस डबल इंटीग्रल को लिमिट्स नहीं है, लेकिन वी कैन ऑब्टेन फ्रॉम द गिवन कंडीशन. सो वी गेट द इंटीग्रल फ्रॉम 0 to 1. दिस इज द फर्स्ट ऑन x axis, and this is the vertical strip. Lowest point of vertical strip is 0. Second 1 minus x, x square प्लस वाई स्क्वेयर dx dy. नाउ वी कैन सॉल्व दिस इंटीग्रल. आता लिमिट्स फिक्स झाले. यहाँ पे देखो वी हैव फिक्स्ड द लिमिट्स, सो वी कैन कॅल्क्युलेट नाउ इंटिग्रेशन. आता सुरुवातीला काय कॅल्क्युलेट करावं लागेल. नाउ दीज आर द व्हॅल्यूज ऑफ एक्स. सेकंड लिमिट्स आर इन टर्म्स ऑफ एक्स. So y is equals to 0 to y is equals to 1 minus x. These are the values of y in terms of x. So we have to take integration first with respect to y. So integral from 0 to 1 minus x, x square plus y square dy by keeping dx x is a constant. मग आता इंटिग्रेशन घ्या with respect to y. x square चे इंटिग्रेशन x square y and y square चे इंटिग्रेशन y cube by 3. So x square चे इंटिग्रेशन x square y plus y cube चे y square चे इंटिग्रेशन y cube by 3. Lower limit is y is equals to 0 to upper limit is y is equals to 1 minus x. Now put the upper limit. y च्या ऐवजी this x square as it is. Upper limit 1 minus x, lower limit minus 0 लिहायची गरज नाही. इथं परत upper limit 1 by 3 as it is. अप्पर लिमिट 1 मायनस एक्स ब्रॅकेट क्यूब. अप्पर लिमिट, लोअर लिमिट 0 असल्यामुळे त्याची व्हॅल्यू 0 होते, लिहायची गरज नाही. नाउ वी कॅन सॉल्व दिस. मल्टिप्लाय बाय दिस. एक्स स्क्वेअर इंटू 1 मीन्स एक्स स्क्वेअर मायनस एक्स मीन्स एक्स स्क्वेअर इंटू मायनस एक्स मीन्स मायनस एक्स क्यूब. कीप दिस एज इट इज. सो अगेन वी हॅव टू इंटिग्रेटिंग विथ रिस्पेक्ट टू एक्स. सो एक्स स्क्वेअरचं इंटिग्रेशन एक्स क्यूब बाय 3. लिहून घेऊ नका रे, फास्ट सर्वांनी आन्सर द्यायचं. मला पाहू द्या तुमची प्रेझेंटी वगैरे घेता येते. सर्वांनी चॅटबॉक्समध्ये आन्सर्स द्या. सो एक्स क्यूबचं इंटिग्रेशन एक्स रेस टू 4y4. 1 मायनस एक्स क्यूबचं इंटिग्रेशन 1 मायनस एक्स ब्रॅकेट क्यूबचं इंटिग्रेशन ब्रॅकेट रेस टू 4 डिवाइड बाय -4. एक्सचा कोइशन काय -1. सो -4 इंटू 3 मीन्स -12. सो put this upper limit and lower limit. So 1 cube means 1 minus 0 cube means 0. Second minus 1 raised to 4 means 1 minus 0 raised to 4 means 0. आणि upper limit 1 minus 1. upper limit जेव्हा ठेवतात ना 1 minus 1 means 0, लिहायची गरज नाही. लोअर लिमिट 0 ठेवा. 1 minus 0 means -1 raised to 4. So in this way we can write minus minus here plus. Then 1 by 3 minus 1 by 4 plus 1 by 12. 4 minus 3 plus 1 divided by 12. So 2 by 12 that is 1 by 6. Okay. So in this way we can write. Okay. अशा पद्धतीनं तो इंटिग्रल होतो. This is the value of double integral. Now we shall solve such a problems. आता असे खूप प्रॉब्लेम्स आहेत आपल्याला सॉल्व करायचे आहेत. ओके. तर या बेस्ड आपण एक 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 प्रॉब्लेम सॉल्व करू. ठीक आहे. हां, नाउ हियर नेक्स्ट इव्हॅल्युएट सेकंड प्रॉब्लेम. इव्हॅल्युएट व्हॉट इज दॅट डबल इंटिग्रल 0 to pi 0 to x sin y dx into dy. So let I is equals to integral from 0 to pi. थोडं चला रे फास्ट आन्सर द्या. डबल इंटिग्रल फ्रॉम 0 to x sin y dx dy. So this second integral having a limit in terms of x, that means y is equals to 0 to y is equals to x. So we have to take this integral with respect to y first. Integral from 0 to x sin y dy into keeping dx constant. सांगा रे sin y चं इंटिग्रेशन काय असतं. इंटिग्रल फ्रॉम 0 to pi. लिहू नका रे, फक्त मला आन्सर द्या. sin y चं इंटिग्रेशन असतं मायनस कॉस y फ्रॉम 0 to x dx. नाउ कीप द अप्पर लिमिट. इंटिग्रल फ्रॉम 0 to pi minus I as it is sin x cos x minus cos 0 cos x minus cos 0. आता cos x ची अप्पर लिमिट ठेवा. cos x cos 0 ची व्हॅल्यू किती असते. चला रे फास्ट सांगा. cos 0 ची व्हॅल्यू 1 असते. सो इंटिग्रल फ्रॉम 0 to pi minus you can take out of integral cos x minus 1 dx. Now again we can take the integration. So minus is it is cos x च integration असतं sin x, 1 च integration with respect to x over the limit 0 to pi. So keep the upper limit and lower limit. That means sin pi minus x म्हणजेच pi, lower limit ठेवा minus sin 0 minus 0. So it will be the minus sin pi means 0 minus pi minus 0 plus 0. So it will be the final answer, it will be the pi. Very good. श्रद्धा, मायावती, सावंत, कालचे होमवर्क फक्त 4 जणांनी केलं आणि साईनाथ शेवार यांनीच फक्त एकदम छान आणि ॲक्युरेट व्यवस्थित लिहून सर्व होमवर्क साईनाथ शेवार यांनी एकदम ॲक्युरेट केलेत. बाकीच्यांनी काही जणांनी शॉर्टकट केलेत. पहा तुम्ही त्याचे जरा प्रॉब्लेम बघत जावा, त्याचे सोल्युशन बघत जावा, ज्यांना जमत नाही त्यांनी, आणि त्या पद्धतीनं तुम्ही समजून घेऊन सॉल्व करत चला. ओके, नेक्स्ट वी शॅल मूव टुवर्ड्स द सेकंड प्रॉब्लेम. Third problem, integral from 0 to log of 8, integral from 0 to log of y e raised to x plus y dx dy. So let I is equals to double integral from 0 to log 8, from 0 to log y e raised to x plus y dx dy. So check this, limits of second integral are in terms of y, means log y. इथं पहा, limits of second integral are in terms of x, so we have to integrate first with respect to y, keeping x constant. But in this case limits of second integral are in terms of y, means it is actually x is equals to 0 to x is equals to log y. These are the limits of second integral. That means f1 of y to f2 of y, means here the strip is horizontal. So we have to take integration with respect to x, because if strip is horizontal then we have to differentiate with respect to x, that is a variable. X is a variable by keeping y constant. So first of all I can write integral from 0 to log 8, integral from 0 to log y e raised to x plus y, means e raised to x into e raised to y dx dy. सांगा बरं आता इथं with respect to x घ्यावं लागेल का y घ्यावं लागेल? Here we have to take integration with respect to y, because see this, the problem is like this, horizontal strip. Second, limits of second integral are in terms of y, f1 of y to f2 of y. So we have to integrate with respect to x first, keeping y constant, because in this case the strip is horizontal. So integrating with respect to y, keep this first, integral from 0 to log 8, integral from 0 to log y, keeping integrating with respect to x. आपल्याला इंटिग्रेशन काय घ्यायचे विथ रिस्पेक्ट टू एक्स, ई रेज टू एक्स इंटू ई रेज टू वाय डी एक्स बाय किपिंग वाय कॉन्स्टंट. आता इथं एक्स न घ्यावं लागतं, वाय कॉन्स्टंट ठेवावं लागतं, इंटिग्रेटिंग विथ रिस्पेक्ट टू एक्स, बिकॉज द लिमिट्स ऑफ सेकंड इंटिग्रल आर फॉर एक्स इज इक्वल्स टू 0 टू एक्स इज इक्वल्स टू लॉग वाय. That means in terms of y, this is f1 of y, f2 of y. If the limits are in terms of y, then we have to take integration with respect to x by keeping a y constant. हे व्यवस्थित लक्षात ठेवा, हे समजलं पाहिजे. ओके, सो इंटिग्रल फ्रॉम 0 टू log 8. Now we can take, if we take integration with respect to x, then y constant e raised to y as it is, e raised to x चा integration with respect to x is e raised to x over the limit 0 to log y with respect to y, keeping a y constant. Okay, so आता अपर लिमिट ठेवा, इथं इंटिग्रेशन विथ रिस्पेक्ट टू काय घेतलेलं आपण, इंटिग्रेशन विथ रिस्पेक्ट टू एक्स घेतल्यामुळं दीज आर द व्हॅल्यू एक्स इज इक्वल्स टू 0 टू एक्स इज इक्वल्स टू log y. Actually x is equals to 0 to x is equals to log y means we have to put in place of x, we have to put in place of x upper limit log y, lower limit 0. So we can write integral from 0 to log 8 e raised to y as it is. Keep the upper limit e raised to x, कारण इंटिग्रेशन विथ रिस्पेक्ट टू x घेतल्यामुळं त्या x च्या व्हॅल्यूज आहेत म्हणून x मध्ये e raised to log y, e raised to log y minus e raised to 0 dy. So integral from 0 to log 8 e raised to y, e चा power log means we can write this as y minus e raised to 0 means 1 dy. Is it okay? So we can write this as integral from 0 to log 8. आता इंटिग्रेशन विथ रिस्पेक्ट टू y घ्यायचे. इंटिग्रेशन विथ रिस्पेक्ट टू y घेत असताना लक्षात ठेवा बरोबर आहे का पहा. इज इट ओके? सो वी हॅव टू कॅल्क्युलेट नाउ. मल्टिप्लाय करा y इंटू e रेज टू y dy minus integral from 0 to log 8 1 into e raised to y dy. ओके, मल्टिप्लाय करा. आता याला प्रोडक्ट रूल वापरा. हाऊ वी कॅन राईट द प्रोडक्ट रूल? फर्स्ट इज इट इज इंटिग्रेशन ऑफ सेकंड ओव्हर द लिमिट 0 टू log 8 मायनस इन इंटिग्रेशन डेरिव्हेटिव्ह ऑफ फर्स्ट, डेरिव्हेटिव्ह ऑफ फर्स्ट y चा डेरिव्हेटिव्ह 1 integration of second e raised to y dy from 0 to log 8. First of all we have to use the product rule. First as it is integration of second, sorry यहाँ पे y है देखो, integration of second means y as it is integration of second over the limit 0 to log 8 minus in integration derivative of first integration of second, y चा derivative with respect to y 1 integration of second e raised to y minus this same integral e raised to log 8 e raised to y dy. So these two one minute, okay, so we can write this as 1 minute. Minus minus means you can write 2, so you can put this as y e raised to y over the 0 to log 8 minus these are the same integral. 1 into e raised to y means e raised to y, integral 2 times of integral from 0 to log 8 e raised to y dy. So e raised to y चा इंटिग्रल काय असेल with respect to y? e raised to y. So y into e raised to y 0 to log 8 minus 2 times of e raised to y 0 to log 8. You have to solve. Usual method ना सॉल्व करा, काही अडचण नाही आहे. सो कीप दिस अपर लिमिट y मीन्स log 8 into e raised to log 8 minus lower limit 0 into e raised to 0 minus 2. Again here keep the upper limit and lower limit. Upper limit means y. So e raised to log 8 minus e raised to 0. Is it okay? So we can write e चा power log असेल, that will be the cancel. So 8 log 8 minus 0 means 0 minus 2 into e चा power log means 8 minus 1. So we can write 7. So 8 log 8 minus 8 minus 1, 8 minus 1 e raised to 0. लोअर लिमिट 1 आहे वाटतं ना रे, 0 आहे, ठीक आहे. ओके, नो प्रॉब्लेम. यू कॅन राईट 8 minus 1 means that is a 7. 7 into 2 means 14. In this way we can write the integral. ओके, अशा पद्धतीनं हे इंटिग्रल सॉल्व होतं. सेम इंटिग्रल you have to solve. Next, बरोबर आहे ना? काही अडचण आली तर विचारा. इंटिग्रल फ्रॉम नेक्स्ट थर्ड, इंटिग्रल फ्रॉम 1 to √2, double integral from minus √4 minus 2y square to 4 minus 2y square y dx dy. Now see this, the limits of second integral are in terms of y, that is f1 of y and f2 of y, means it is compared as x is equals to f1 of y, x is equals to f2 of y, means in this way, as like this second integral, second type, these are the x is equals to f1y, f2y, means horizontal strip. मला सांगा बरे स्टुडंट, मग विथ रिस्पेक्ट टू कुठली टर्म अगोदर इंटिग्रेशन घ्यावं लागतं, हे खूप महत्त्वाचं आहे. विथ रिस्पेक्ट टू फर्स्ट इंटिग्रल काय घ्यावं लागेल, I इज इक्वल्स टू इंटिग्रल फ्रॉम 1 to √2 इंटिग्रल फ्रॉम मायनस √4 minus 2y square to root of 4 minus 2y square y dx dy. विथ रिस्पेक्ट टू काय घ्यावं लागेल रे, -14. ओके, सांगा रे. So first of all we have to take integration with respect to y, because these are the limits in terms of y. So these are the values of x in terms of y. So minus √4 minus 2y square plus √4 minus 2y square y dy dx. First of all we have to take the integration with respect to x by keeping y constant. By keeping y constant, लक्षात ठेवा रे, सेकंड इंटीग्रलचे जे लिमिट्स y मध्ये असतील, अगर यहाँ पे सेकंड इंटीग्रल के लिमिट y में होते तो यू हैव टू टेक इंटीग्रेशन विथ रिस्पेक्ट टू x. हियर वी हैव टू कंसिडर स्ट्रिप इज हॉरिझॉन्टल. नीट लक्षात घ्या. सो इंटीग्रल फ्रॉम 1 to √2, if we take the integration of y with respect to x, then y keep as a constant, integration of dx is x over the limit root of minus 4 minus 2y square to root of 4 minus 2y square dy. Keeping y constant with respect to x घ्यावं लागतं. परत एकदा नीट लक्षात घ्या, हिंट लक्षात घ्या. सेकंड इंटिग्रलच्या लिमिट्स मध्ये जर y असतील तर इंटिग्रेशन विथ रिस्पेक्ट टू x घ्या, आणि एक्सच्या फॉर्ममध्ये असेल तर इंटिग्रेशन विथ रिस्पेक्ट टू y घ्या, म्हणजे हॉरिझॉन्टल व्हर्टिकल स्ट्रिप. तर आता ह्याच्या व्हॅल्यूज घ्या. इंटिग्रल फ्रॉम 0 to 1, हां काय पहा, 1 to √2. नाउ y as it is, these are the limits for x, these are the limits for x. So y as it is, keep upper limit. आता वरचा लिमिट ठेवा, वरचा लिमिट ठेवला तर काय पहा, y च्या जागी x च्या जागी अप्पर लिमिट ठेवा. these are the values of x, we are in differentiating with respect to x, so we have to we are integrating with respect to x, so we have to put the limits in terms in the place of x. So upper limit root of 4 minus 2y square, root of 4 minus 2y square minus plus root of 4 minus 2y square. Okay, so it will be the dy. That means we can write I is equals to integral from 1 to √2, root means 2 root 2y into root 4 minus 2y square into dy. So put, आता इथं लिमिट सबस्टिट्यूशन मेथडनं सॉल्व करा. वी हॅव टू सॉल्व दिस बाय यूजिंग द सबस्टिट्यूशन ऑफ लिमिट. लिमिट सबस्टिट्यूशन सॉल्व करा. पुट t इज इक्वल्स टू 4 minus 2y square. So dt is equals to 0, means 4y minus 4y dy. So So dt upon minus 4 is equals to y into dy. Again we have to change the limits. We shall change the limits. Lower limit when y is equals to 1, इथं ठेवा 1 ठेवा, तर 4 minus 2 means then t is equals to 2. आता अपर लिमिट ठेवा when y is equals to root 2, then अपर लिमिट ठेवलं तर काय येतं पहा, root 2 चा स्क्वेअर means 2, 2 into 2 means 4, t is equals to 0. So our integration becomes I is equals to integral from 2 to 0. Now 2i is, it is y dy, this y and dy we can replace it by dt upon 4 root t into 2 जसे असतं तसं dt minus dt upon 4. So I is equals to minus 1 by 2 integral from 2 to 0 root t dt. Now by the property of definite integral we can change the limit 0 to 2 t raised to 1 by 2 dt. हे मायनस रिमूव्ह करा, लिमिट्स इंटरचेंज करा. सो नाउ t raised to minus 1 by 2 चं इंटिग्रेशन काय आहे तर स्टुडंट सांगा बरं. 1 by 2 is it is t raised to 3 by 2 upon 3 by 2 over the limit 0 to 2. So 1 by 2 into 2 by 3. You can take this 2 by 3 out of this integral. So we can write t raised to 3 by 2 over the limit 0 to 2. Put the upper limit and lower limit, which will be the 1 by 3. Upper limit means 2 raised to 3 by 2 minus lower limit 0 raised to 3 by 2. So 1 by 3 into 2 raised to 3 by 2. 2 raised to 3 by 2. काय येईल पहा? 2 चा क्यूब 8 रूट 8 बरोबर आहे का रे? हाँ लिमिट्स पहा पर 0 टू लिमिट्स काय येतात बघा बरं रे. लिमिट 0 टू 2 ची येतं ना. इफ वी पुट हाँ 1 ठेवलात t इज इक्वल्स टू 1. करेक्ट आहे का पहा बरं हे सर्व. रूट 2 ठेवलं तर काय तर रूट 2 चा स्क्वेअर 2. आणि इफ वी लोअर लिमिट t इज इक्वल्स टू 1 ठेवलात, 1 ठेवल्यानंतर काय येतं पहा 1 ठेवलात 1 चा स्क्वेअर y इज इक्वल्स टू 1, 1 चा स्क्वेअर 2 minus 2 means इज इट ओके. सर इथं काय येतं पहा 2 root 2. So it will be the 2 root 2 divided by 3. हे व्हेरीफाय करा एकदा, काही अडचण नाही, तुम्ही व्हेरीफाय करू शकता. ओके. नाउ वी शॅल मूव टुवर्ड्स द नेक्स्ट इंटिग्रेशन ऑफ नेक्स्ट प्रॉब्लेम. डबल इंटीग्रल फ्रॉम 0 to 1, integral from 0 to root of 1 plus x square 1 upon 1 plus x square plus y square dx dy. So let I is equals to double integral 0 to 1, 0 to root of 1 plus x square 1 divided by 1 plus x square plus y square dx dy. आता सांगा बरे सुरुवातीला कशाचं इंटिग्रेशन घ्यायचं, कोणत्या टर्मने इंटिग्रेशन घ्यायचं. फर्स्ट ऑफ ऑल यू टेल मी. We have to take this integral, second integral with respect to, because see this, the lower limit is 0, upper limit is root of 1 plus x square. That means in terms of x, that is f1 of x to f2 of x in terms of x. If limits are in terms of x, then it is the vertical strip. Limits are in terms of x, then it is a vertical strip. That means we have to take integration with respect to y first, keeping x constant. So integral from 0 to 1, integral from 0 to root of 1 plus x square 1 upon 1 plus x square plus y square dy, keeping x constant. Integral from 0 to 1, 0 to root of 1 plus x square. We have to use the standard formula x square plus a square. For this purpose, we have to change this function root of 1 plus x square bracket square plus y is a variable because integrating with respect to y. So, y is a variable dy into dx. So, what is the standard formula for this? 1 upon x square plus a square. Who can tell me what is the standard formula? 1 upon x square, integration of 1 upon a square plus y square dy असेल. तो 1 by a tan inverse of y by a. This is the standard formula 1 upon a square plus y square. So a square means, a means root of 1 plus x square bracket square. So a square plus y square. So we can write this as 1 upon a means 1 upon root of 1 plus x square into tan inverse of x by means y by a root of 1 plus x square. Okay, so the limits are, limits कुठले आहेत पहा, 0 to, keep this integral as it is, 0 to 1, limits are 0 to root of 1 plus x square, this dx integral as it is. Now we can use upper limit and lower limit. Upper limit is root of 1 plus x square, lower limit is 0. So I is equals to, first integral as it is 0 to 1, 1 upon root of 1 plus x square. Keep the upper limit tan inverse of, upper limit means in place of y, because we have integrated with respect to y. So integrating with respect to y, so upper limit is y in place of root of 1 plus x square divided by root of 1 plus x square minus lower limit means tan inverse of 0 divided by root of 1 plus x square, keeping this integral as it is. So we can write I is equals to integral from 0 to 1, 1 upon root of 1 plus x square. इथं काय राहिलं पहा, tan inverse 1 minus tan inverse 0. Solve this complete first. So integral from 0 to 1, 1 upon root of 1 plus x square. Tan inverse 1 means pi by 4 minus 0, there is no problem. So pi by 4 is the constant. Integral from 0 to 1, 1 upon root 1 plus x square dx. So 1 upon root 1 plus x square, पुन्हा ह्याचं इंटिग्रेशन log of, आठवतंय का पहा, integration of 1 upon root of a square plus x square, then log of x plus root a square plus x square. Okay, so we have to take this integral. So pi by 4 into log of x plus root 1 plus x square over the limit, limits कुठले आहेत पहा, 0 to 1. So we can write pi by 4, keep this upper limit as 1, log of x च्या जागी 1 ठेवा, 1 plus root 2 minus log of 0 plus 1. 1 plus 0 square means 0, so 1 plus 1. That means pi by 4 into log of 1 plus root 2 minus log 1. Log 1 ची व्हॅल्यू 0 असते, so final answer is pi by 4 log of 1 plus root 2. दिस इज द कंप्लीट आन्सर ऑफ द डबल इंटिग्रल. ओके, असे खूप प्रॉब्लेम्स आहेत, बरेचसे प्रॉब्लेम्स आहेत, तुम्हाला सॉल्व करता येतील. काही प्रॉब्लेम्स राहिलेले आहेत ते आपण परत उद्याला घेऊ. ओके, सो टुडे देर विल बी नो एनी होमवर्क फॉर यू. होमवर्क काही गरज नाही आहे तुम्हाला, तुम्ही काल केलेलंच आहे. ओके, काही प्रॉब्लेम्स आहेत असे आपण ते उद्याला घेऊ. सो वी शॅल टेक द प्रॉब्लेम्स बेस्ड ऑन दिस टुमारो. उद्याला आणखी प्रॉब्लेम घेऊ. काय अडचण, इफ यू हॅव एनी डाऊट देन यू कॅन आस्क. If you have any doubt then you can ask. Okay.